Hello everyone, welcome back, and today's topic is chapter 3, a pair of linear equations in two variables. And let's take a minute to see what we shall study in this video class, and that's everything. No, not literally, but almost everything, because we are not going to cover all the questions of the exercises. However, for the exercises we are going to make a separate video. In the first part we are going to see to the introduction of a pair of linear equations in two variables, and since you got a linear equation in one variable and how to solve it in previous class, and you also got linear equations in two variables and how to plot them on a graph in your previous classes, hence we shall come to the introduction part, which is quite important because that will include the fundamental concepts behind simultaneous linear equations in two variables, and it's very important to understand the topic from its roots. Then we shall go for the solving of the linear equations, which includes two methods, where the second method is again subdivided into three other methods. The first method is graphical method, which uses graph definitely and plotting these lines as you did in your previous class on the graph paper to solve for the two variables. And then comes the algebraic methods, where the solving of pair of linear equations is done using three techniques: the substitution method, elimination method, and cross multiplication method. And the last part, which is equations that are reducible to a pair of linear equations in two variables. Now these equations on the first look doesn't look like a linear equation. They are non-linear at first place, but they can be reduced to a linear equation, and some are not even polynomials. We know how to solve polynomials, and you will find some equations which are not even polynomials, but we will be able to reduce them into linear equations and then solve it. After you go through all the theories in this video, it will become very easy for you, but those converting the word problems is the real deal in this chapter that you gotta win. Okay, and we shall also be describing the graphical part and algebraic methods. We shall be solving with examples, and I shall explain you enough that it should make you able to solve any questions which can be brought into the general form of pair of linear equations in two variables. So let's begin and try to finish the chapter within an hour. The first thing that you need to do is recall polynomials. You studied polynomial or linear polynomials in previous classes, and in a chapter back you studied about polynomials, and the linear polynomial was ax plus b, where a is not equal to 0. When do we call linear? If the exponent of the variable, now here x is a variable, in the expression takes the maximum value 1. So what is the exponent of the variable here? 1, and that is the maximum value in this entire expression. Then it's linear, and I hope you remember that the exponents can take only whole number. These exponents here can take only whole numbers, 0, 1, 2, 3, 4 and so on, right? So ax plus b was in one variable x. Now we see how a two variable or a linear expression looks like, and that's ax plus by plus c, where a and b both are not equal to 0. You can't write it like this, a, b not equal to 0. It's not like that. Either of them can be 0, but both together cannot be 0, because if both a and b become 0, then we will be left with only a constant, which is only a number, and that is not linear, because a constant comes with a variable. You can give it x, and the power of the variable is 0, and obviously that is a 0 degree polynomial. It's not linear, and hence this long line here, which I will erase, can be written in a shorter manner but differently, and that is written like this: a square plus b square is not equal to 0. Now you see, where a is not equal to 0, b is not equal to 0, then why do we write the expression like this: a square plus b square not equal to 0? Now this condition is also a one marker question which you might get in your exam, that if ax plus by plus c is a linear expression, then what is the conditions that the coefficient of x and y satisfies? So this is your condition. And why this condition becomes true? Because a square is greater than equal to 0, b square is also greater than equal to 0, and hence a square plus b square will definitely be greater than equal to 0. We know that the square of any number, whether it is positive, negative or 0, it have to be greater than equal to 0. The sum of the squares will be 0 only if both of them are zeros, right? A square have to be 0, b square also have to be 0, only then their sum will be 0. And when will be a square equal to 0? Only if a is equal to 0. And when will be b square equal to 0? Similarly, when b is equal to 0. Hence we write the conditions like this, okay? A square plus b square not equal to 0. Now it was said expression. If it was said an equation, then we have to put a equality sign, and since this a, b, c are arbitrary, that is there any constant, hence we can equate it 0. Now we could also equate it to another linear equation like this. We could also equate it to another linear equation like this. We could also equate it to another single variable linear equations like this, but we can also equate it to a constant also. But ultimately, since a, b, c are arbitrary, we can bring all of them into the form of ax plus by plus c equal to 0. You must try it yourself in your home. Why, even if we equate it to some other linear or linear in two variables or linear in one variable x or one variable y or some constant, even then why can we bring that into the form of ax plus by plus c? Now this is the form. It doesn't mean your coefficients have to be a and b and c. The form have to be like this. Your a, b and c can take any value, whatever value it takes. It will be ultimately a linear equations, but there is a restrictions for you, that is the values for a, b and c should be real numbers. We are considering only for real numbers because you have not studied complex numbers and other things, hence real number is our limitation for a, b and c. So let's get into the general form of linear equation, which is ax plus by plus c equal to 0. This is our general form of linear equation. Now this is only one equation, but we are to study pair of linear equations, and that too also in two variables. So why a pair of linear equations? Now you studied linear equations in single variable ax plus b equal to 0, and you could easily solve it and find that x is equal to minus b. If you take transpose b on the right and then divide by a, it would become minus b by a. In polynomial also you came across a question, what is the solution for a linear polynomial? That is equal to minus b by a. That is the only solution. And for example, instead of the variables and arbitrary constants, if we write real constants 2 and 3, then what is x is equal to in this case? It is minus 3 by 2. And as you can see that we could find the value of x in a single equation. Why? Because this equation has only one variable, that is x. Is it possible for two variables? That is, if we had two variable equation like that ax plus by plus c, then can we find the value of the two variables with a single equation? Now let us see it with an example. The number of boys and the number of girls in your class, for example, let it be 30. So can you say me what is the number of boys and number of girls in a class of 30? Can you say? No, you cannot say, right? Some of you might have guessed the numbers, like it can be 0 boys and 30 girls, right? It could be 1 boy and 29 girls, and like this, so on. You can continue, and that would be up to 30 boys and 0 girls. So how many possibilities are here? We are starting here from 1, right, and we are reaching to 30. So here there will be 30 possibilities, and here we have another one. So total 31 possible answers are there. Now that's a counting thing. Let's get back to our question. So in all these values or all these possible answers, we could not find the exact number of boys and exact number of girls with a single condition provided to us. So what was the single condition? That the number of boys and the number of girls when added together, when taken together, it is 30. So that is a condition and we can form an equation. And if I give you another condition, that is the number of boys is 6 more than the number of girls. If you have x number of boys and y number of girls, then if you add 6 to y, only then that would be equal to the number of boys. Now that's an equation, right? We'll come back to it again. So can you guess now? Yes, some of you can guess the number 12 and 18, and some of you would guess the number 18 and 12. But which is the correct one? If you guess 12 and 18, then it would be wrong, since the number of boys is greater than the number of girls. Hence it should be 18 first, that is the number of boys is 18 and the number of girls should be 12. If you notice, then we needed two conditions and we could find the exact value for x and y, or you can say the number of boys and the number of girls in the class. And had we written it in the equation form, we would have this equation. Say number of boys is x plus number of girls is y, and that gives us 30, and the other one would be x is equal to y plus 6, and this can easily be reduced to if I take y on the other side, then I can write x minus y equal to 6. So these are two equations and hence a pair of linear equations. So we need a pair of linear equations in two variables, your x and y, right? Two variables to solve. Now this was a very simple one, and hence guesswork or hit and trial could be done easily by many of you. What if the equations were more complicated? For example, if it was 3x plus 2y equal to, for say, 78, then can you do the guesswork in that case? Okay, let me give you two equations only, and let me write here 5x minus 3y is also equal to 70, not 78, that would be 54. Can you do the guesswork now? Well, the answer is same, 18 and 12. For x, here also it will be 18 because 3 18s are 54, and 2 into 12 is 24, so 54 and 24 is 78. And similarly 5 into 18 is 90, and 3 into 12 is 36, so 90 minus 36 is 54. So here also the value for x is 18 and the value for y is 12. The equations are different this time. Earlier it was x plus y equal to 30 and x minus y equal to 6. Now the equations are different, but we are getting the same answer. So two different set of simultaneous equations can have the same set of solutions. Okay, here the set of solution is 18 and 12. Here I could write this equation because I have done the calculation before writing the answer 78 and 54. So then what do we do? So where guesswork ends, there starts the mathematical algorithms, and we have 4 such ways to study this year for solving linear equations in two variables. We need a pair of linear equations, so we are writing a1, b1, c1. So this is one equation, and then we are writing a2x, b2y and c2 as the second equation. Let's recall the conditions that we had. a1 square plus b1 square is not equal to 0, and a2 square plus b2 square is also not equal to 0. And we have another condition, that is a1, b1, c1 and a2, b2, c2 are real numbers. So this is our entire and complete definition of a linear equation, of a pair of linear equations in two variables Here the variables are x and y, and a1, b1, c1, a2, b2, c2 are arbitrary constants, that is there can be any real number. And now let us go to the graphical method of solving it, and for that we need to look at the last thing in the part of introduction. So let us take two lines. So these two lines can either intersect, or they might never intersect, or there might be overlapping of one another, right? So whenever this two is the case, that is the two lines have one or more than one point common. When it is having one point common, exactly one point common, then the lines are intersecting. And when it has more than one point common, then it overlap, or you can say the lines coincide. Whenever these two conditions happen, we call that the system of linear equations are consistent. That means they have solutions. Whenever two equations have a point in common or more than one point in common, we say that it is consistent in nature. But then again, consistent pair of linear equation is divided into two, right? In one, the consistent pair of solutions, and the other one dependent consistent pair of solutions. And whenever the lines are parallel to each other, that is they don't intersect, then they are called inconsistent pair of linear equations, do not have any solution. Let us look into a table which will give us a gist of all the conditions, the graphical representation, the algebraic representation, and the conditions that the coefficients satisfy for the pair of linear equations in two variables. So two lines, a1x plus b1y plus c1 equal to 0, one line, and the other line a2x plus b2y plus c2 equal to 0 are consistent pair of linear equations if graphically the lines intersect, or algebraically the lines have unique solutions. That is, after solving we get one and only one solution, or one value of x and y which satisfies both the equation, or the condition of the coefficients. That is, if a1 by b1, that is this coefficient by this coefficient of x, is not equal to the ratio of the coefficients of y, okay, then also you can say that the pair of linear equations will be consistent and it will have unique solution, and graphically it will intersect. And if these two lines, the coefficients satisfy this condition, that is the ratio of the coefficients, corresponding coefficients of x, y and the constants are equal, then it will have infinitely many solutions. That is, there will be infinite solutions, that is the lines will be overlapping each other, okay, that is they coincide, and they are called dependent or consistent pair of linear equations. So all of them are interrelated. If it is dependent or consistent pair of linear equations, you can say that graphically the lines are going to coincide, and algebraically it will have infinite number of solutions, and the coefficients will satisfy this given condition where a1 by a2 is equal to b1 by b2 equal to c1 by c2. And if these solutions, or these lines are parallel, then they will be called inconsistent pair of linear equations, and inconsistent pair of linear equations are graphically parallel, algebraically they don't have any solution, that is they don't have any common point, and their coefficients also satisfy this given condition where a1 by a2 is equal to b1 by b2. They are equal, but the constants proportions are not equal to the other two. Here in the conditions you must see this, always find a1 by a2 and b1 by b2 first, and if you get this result a1 by a2 is not equal to b1 by b2, then don't go to find c1 by C2. I have seen many students do that, but don't do that. It is not necessary. When it is already not equal, you can say that they are consistent pair of linear equation intersecting and they have unique solutions. But only if they are equal, only then move on to find C1, C2, and if C1, C2 is also equal, then the middle condition satisfies, and if it is not equal, then the lines have to be parallel with no solution and it will be inconsistent. So do note this table, okay? Pause it and you can note it down. I hope you have noted, and now we can move on to the graphical method of solving a linear equation. Now in the graphical method, let us solve the two equations. The first thing that you need to do in graphical method is write either x or y in terms of the other variable. For example, we are going to write x in terms of y. Here we can write twice x is equal to, if we transpose this 3y on the other side, it will be 1 plus 3y, and then we can write x as 1 plus 3y divided by 2. That is, we isolated x and we wrote it into the form of y. Similarly, for this variable also, this equation also you need to do it, and we can write thrice x is equal to 7 minus y, and then if we take 3 on the other side, it will be 7 minus y divided by 3. So now we need to find the points that are things that you have done in your previous classes. We need to find points for which the equations will be satisfied. So for the first one, we are going to find such points, and you need to assume such values of y so that you can plot them in the graph. Now don't try to assume 1000 for in this case. If you write 3 into 1000 plus 1 divided by 2, that would become 3 into 1000 is 3000. 3000 plus 1 is 3001. 3001 divided by 2 will be equal to 1500.5. Obviously plotting 1500 on graph would be tougher for you, and hence try to find smaller points which will be easily plotted on the graph. For example, if you see that it is 1 plus 3y divided by 2, that means if I wish to make the numerator 1 plus 3y even, then I can divide it by 2 and I will get a normal integer, right? If I choose y equal to 1, then you see what will x become? It will become 1 plus 3 into 1, right? Divided by 2. So when I choose y equal to 1, then it becomes 3 into 1, which is equal to 3. 3 plus 1 is equal to 4, and 4 divided by this 2 will be equal to 2. So our x will be equal to 2. Try to recall this thing. So that odd into odd is odd number, and then odd plus odd is even number, and that is what I am using here. Hence I chose y as an odd number. You choose an even number and you are going to get 1 plus 3y as a odd number, because 3 into 3 is an odd number, so odd number into a even number will become an even number, and even number plus 1 would become an odd number. So 1 plus 3y, the numerator will become an odd number, and odd number divided by 2 will give us a fraction. Hence I will choose another odd number, which is 3 after 1, right? I could have chosen 0 also, but if I choose 0, then it will be 1 by 2. So I will choose 3. Hence if I choose 3 for y, then it will be 3 into 3, which is 9. Then we have 1 we need to add, so that is 10, and 10 divided by 2 is equal to 5. So when y is 3, x is equal to 5. So before writing on the table, do your calculation beforehand. And normally you don't need to choose the third number, because 2 points will give you the straight line, but the third number is a checking point that will also check whether your all the calculations that you have done is correct or not. That will also check whether the line that you are drawing in the graph is actually straight or not, because if it is not straight, then the 3 points will not be collinear, they won't be in the same line. Hence it is for accuracy also, and it is for checking also. Hence I always recommend the third point, but if you are very much sure and expert in drawings, then you can avoid this third point. Many students I had who never chose the third point because their drawings were very much clean and clear. The pens or the pencil they used to be very much sharp, and hence it was a crystal clear graphical representation. They never chose the third point, and while doing the calculations they took sufficient care to be right. So anyway, let us choose a third point, and I will choose 5, the next odd number. So if it was 5 in place of 3, it would be 3 into 5 is 15. 15 plus 1 is 16. 16 divided by 2 is equal to 8. So when it is 5, x will be 8. Now look at the other equation. Now you have x equal to 7 minus y divided by 3. In the denominator you have 3. That means you need to choose y in such a way so that the numerator becomes a multiple of 3. So if I choose y equal to 1, then 7 minus 1 is equal to 6. 6 is a multiple of 3. Hence 6 divided by 3 is equal to 2. Next I will choose, in place of y, I will choose 1, and that will be 4. I will choose 4. So if I choose 7 minus 4 will be equal to 3, and 3 divided by 3 is equal to 1. Can I choose 0? If I choose 0, then it will become 7 divided by 3, which I will avoid it because drawing it in graph would be difficult for me. And then I can also choose 7 for y, right? Because you see, if I write 7, then 7 minus 7, that would be equal to 0. Hence 0 divided by 3 is 0. So now we need to point this x's and y's in the graph paper. In the first case you have the point 2, 1. Here you have the point 5, 3. You have to point 8, 5, then 2, 1 here, 1, 4 and 0, 7. We need to plot these 6 points on the graph. These 3 points will give us, when we join these 3 points, it will give us the first line. When we join these 3 points, it will give us the second line, and the point of intersection, if any, if it is parallel or if it is overlapping over each other. We will see everything in the graph itself. So now the graph, and without the graph paper also we can do the graphical representation, and I will show you how. Now if you notice, all the points here are in the positive side only, hence only the first quadrant will be enough for the graph. But anyway, I'm just extending it a bit. The lines are drawn here, the y-axis here, and here we have the x-axis, and then we need to point all the points. Remember, the scale that you are choosing should be very much precise, okay? And if it is not precise, your graphs are not going to be accurate, never, okay? In case of lines, in case of linear equations, it is very important that the scale that you place should be very much accurate. So what is the first point that we have? We have 2, 1, 5, 3 and 8, 5. So 2, 1. So where is 2, 1? We have it 2 here, and 1 would be here. So then we have 5, 3. So 5 we have here and 3 we have here. So the common point would be this one, 5, 3. And oh, not accurate. We have to fix it more better. Okay, and then you have the other point 8, 5. So 8, this is 8, this is 5, and in the plain paper, if you want to draw it, you can just draw a straight line like this. Then you have another straight line, and then that would be your point of intersection, right? Those two lines. So as you see, the 3 points are collinear, right? So you use the ruler to draw the lines. Take your ruler to the position of all the 3 points. As you can see, they are coinciding on Yes, I'm drawing in the computer, hence not that accurate, but you cannot be wrong. It have to be very much accurate when you're drawing it in the graph paper. So this is our first line. Similarly, we will plot the other 3 points and draw the next line. On the 3 points, you draw the line. Here, luckily, you already have 2, 1 common to both the lines. That is this point this is A and this is also D. This is point B, this is point C, this is E, and this point is F. Alright, and you have seen that here A and D both are same, 2, 1, 2, 1. Hence, automatically the solution is 2, 1 itself, and you can see that in the graph also. Not in all cases you are going to get 2, 1, you are going to get the same point, but graphically you will have to represent it. And consider that you don't know that 2, 1, so what you need to do is you have to draw a perpendicular from this point to both the sides. So the first perpendicular, if you draw from this point, the point of intersection, it intersects at the point 2. Similarly, you need to draw the perpendicular from the, this is 89 degree, okay, forget it, it was anyway, this is 0, okay, so we have it, that's another line perpendicular that we have drawn, and you can see that the point of intersection in the x-axis is 2, hence this point is 2, and in the y-axis it is 1, hence it is 2, 1. So the graphically we got the solution as 2, 1. Since the lines are intersecting, hence there is a unique solution. So what we write here is, hence the required solution is x equal to 2 and y equal to 1, and this will be your entire representation of the graphical method. Okay, so let's move on to the next part. The first of the algebraic method is the substitution method, and we have taken the same equations that we have taken in graphical method, and we will see whether the answers using different methods are same or not. So in the graphical method we got the answers 2, 1, and let us see for the same equations using substitution method. And the equations are 2x minus 3y equal to 1, the first equation, and the second equation is 3x plus y equal to 7. So what we need to do is, just like the graphical method, we write x in terms of y. So for that we take this 3y on the right hand side, and hence the right hand side becomes 1 plus 3y, and then we take the coefficient of x2 on the other side, and hence it will be divided, because on the left hand side it is being multiplied. So we need to use this value of x in the next equation, that is 3x plus y equal to 7, and hence it becomes 1 plus 3y divided by 2 plus y equal to 7, and then we need to simplify it, and you can see that it is a equation, linear equation in only one variable y, and hence we can solve it very easily. Where in the first term you can see 3 is being multiplied with 1 into 1 and 3y, so it will become 3 plus 9y divided by 2, right? And then if we take the 2 LCM, then that y will be multiplied to 2 and we will have plus 2y, so that will be equal to 7, and then on adding 9y and 2y it will become 11y, and 2 if we take on the right hand side, it will be 14, and then we can take the 3 on the right hand side. On the left hand side we will only be left with 11y, and that will be equal to 14 minus 3, and hence it will be equal to, y will be equal to 14 minus 3, which is equal to 11. So that 11 will be divided by the coefficient of y, which is 11, hence 11 by 11, and therefore we will get y equal to 1, and this 1 we are going to use in any of the equation. Whichever equation you feel right, you can use it. I am going to use it in the equation 3x plus y equal to 7. So 3x plus y equal to 7 implies 3x, and y we just got it equal to 1 equal to 7, and hence we write 3x equal to 6, because 1 on the other side will be 7 minus 1, and hence we get x is equal to 6 by 3, which gives us x equal to 2, and therefore the required solution is x equal to 2 and y equal to 1, which is same as the solution in the graphical method, that is x equal to 2 and y equal to 1, right? So let us move on to the next type of algebraic method, which is the elimination method. In substitution, we substituted the linear equation in two variables as a linear equation in one variable, as you can see in this line. We made a substitution using the first equation in the second equation, and we made it a linear equation in a single variable y, right? And in elimination, what we are going to do is we are going to eliminate any one of the variable by doing some mathematical operations, and we are going to take the same equations in this method also. So the equation 2x minus 3y equal to 1, we have taken it to be the first equation, and the next one we have taken 3x plus y equal to 7 as the second equation. Now in elimination method, the technique we follow is we need to remove any one of the variable. So for that you need to look at the coefficients of the variables. So first notice is, if any one of the coefficient any of the variable have same coefficients, then directly subtract the equations, one equation from the other, any one. And if for example you take it if it was 3x instead of 2x, then you could have subtracted it directly, that is 1 minus 2, you would get x eliminated. If it was opposite in sign, say it is minus 3x and the other one is 3x, then you add them, then the x term would get eliminated. But here the cases are different, here the coefficients are not same. So when the coefficients are not same, you just interchange and multiply the coefficients, whichever seems the easiest. So we could multiply 3 to the first equation, right, and that would give us 6x, and then we multiply 2 to the second equation and it could give us 6x again. Yes, we will also have to multiply 3 to these two terms and 2 to these two terms also, but we are concerned in eliminating x for the first case. But if you notice, in the second equation you have a y, and in y the coefficient is 1, and hence if you just multiply the second equation, right, so that would mean multiplying this one with minus 3, the coefficient in this second equation will become minus 3 for y, and the minus 3 into 3 would become minus 9x, right? So then our coefficients becomes same in the first equation for y and in the second equation for y. We'll just do it and you'll see it. That would be more easier. instead of explaining like this. So see how I write it. I write 1 and then I subtract minus 3 into equation 2, and that would imply, so I will write the first equation because I have not multiplied anything to the first equation. I will write the left hand side of the first equation just like it is, 2x minus 3y, right? You can give the bracket if you want. In the first equation actually it is not so necessary, in the second one it is important. So now we give the minus sign for this minus sign, okay? Then just start the bracket and do the multiplication of minus 3 with the left hand side. So minus 3 into 3x would be minus 9x. Then you need to, oh, here we are subtracting. No, we should not subtract, we should do the addition. Whenever there is addition, you can even remove the bracket. You don't need the bracket, you can directly write the signs, okay? So we will write it like this only, 9x. Only if it is negative here, okay, then give the bracket after the negative sign, because then signs will change, alter. So 9x, and then minus 3 should be multiplied to this y, and that would give us minus 3y. Sorry, I mixed up, it should have been minus only, and it should be within the bracket only. So here the minus sign and the bracket, because we are making the coefficients same, and hence when the coefficients are same, as I told you just a minute ago, that we should subtract. So the subtraction, okay, this subtraction, and minus 3 with the y, it is minus 3y, and then minus 3 have to be multiplied with the 7 also. So on the right hand side this one is not changed, hence we write 1, and then since we are subtracting we give the minus sign, and minus 3 should be multiplied to minus minus 3 should be multiplied to 7, so it is minus 21. So here we have this 3y and this 3y will get cancelled, and you will see how. Twice x minus 3y plus 9x plus 3y equal to 1 plus 21. So as you see, this 3x and 3y and 3y get cancelled, and you have 11x equal to 22. 21 plus 21 is 22. So x is equal to 22 by 11, which is equal to 2. So when you get the value of x, use this value in any one of the equation and you can get your answers. So using the same technique as in the substitution method, what we did is we substituted the value of x in the first equation. In this equation, twice x minus 3y equal to 1, and in place of x we substituted the value 2 that we just got now, and hence it is 2 into x, not this is not x, 2 into x minus 3y equal to 1, and hence 2 into 2 is 4. 4 on the other side, if you take it, it becomes minus 4, and so you have y equal to 1 minus 4 is minus 3, right? So minus 3 divided by minus 3, which is the coefficient of y here, we get y equal to 1. So the required solution is x equal to 2 and y equal to 1. The last one of the algebraic method is the cross multiplication method, and in this method you see the linear equations are being written: a1x plus b1y plus c1 equal to 0 and a2x plus b2y plus c2 equal to 0, and on bottom of it I have written the coefficients starting from the coefficient of y, right? And that is b1 b2 and c1 c2, then a1 a2, and I repeated the coefficient of y. So this part would give us the denominator of x in this expression of ratios. Then here it will give us for y, and here it will give us for 1. 1 means the constant part, and what we need to do is you need to cross multiply them, and hence it is cross multiplication. So b1 into c2 and b2 into c1. So what we need to do is the first cross, b1 into b2 c2, we need to multiply them and write at the first place, and then we need to subtract the second product, which is b2 c1, right? Similarly, you need to multiply c1 into c2 and then subtract the multiplication of c2 into c1. So c1, I'm saying c2, it is a2, right, minus c2 a1, and the last one is a1 b2 and a2 b1, and that would be a1 b2 minus a2 b1, right? And that will give us the value for x as, if you take this denominator b1 c2 on this numerator, you can take this two equation, these two ratios, right, x by this b1 c2 minus b2 c1 and 1 by a1 b2 minus a2 b1, that will form an equation, and hence you can take the denominator of this first or the left hand side to the right hand side, and it will become b1 c2 minus b2 c1 divided by a1 b2 minus a2 b1. Similarly, for y also you get the result. If you take these two sides, right, the denominator of y would go to the numerator, right, and we shall have c1 a2 minus c2 a1 by a1 b2. In both cases the denominator is same, as you can see, and that's the formula that we get for x and y. But in reality the cross multiplication is not giving us the formula for x and y. This is the formula for x and this is the formula for y. However, in reality the cross multiplication is not giving the formula. This is our cross multiplication method, but the elimination method is actually giving the formula. So the first equation, if you multiply with a2, and the second equation if you multiply with a1, okay, so then you are going to have on subtraction, right, here we subtracted after multiplication the first term, which is of x, will be eliminated, because the first term after multiplication of a2, it will become a1 a2 x for the first equation, and for the second equation it will become again this a1 a2 x, right, and on subtraction they will get cancelled out, and we will be left with whatever you can see here, that is a2 b1 minus a1 b2. That will be the coefficient of y after you take y common. You can try that elimination and try to do the proof, and you will have the constant also there, and later on if you take this term c1 a2 on the other side, on the right side, then it will become minus, let me keep it in bracket only, and c2 a1, right, and here you have the coefficient of y a2 b1 minus a1 b2. If I take a minus common, then it will become minus a1 b2, and then it will be minus a2 b1, and I can take it on the right hand side, because after I take this on the right hand side, this will be a product with y. Hence, if I take it to the right hand side, it will be divided, and hence this subtraction and subtraction will get cancelled, and we are going to get y equal to this part. As you can see here also, y is equal to C1 A2 minus C2 A1. Now looking all those things is confusing. You need to do it yourself. Try to solve the linear equations in two variables, that is the general form, using the elimination method. You do it, and these things will be very much clear after that. Otherwise, just naming them, it becomes time taking. So just use the elimination method and multiply this A2 with the first equation and A1 with the first equation, and try to find the value for x and y, and you are going to get the answer. And by answer I mean the formula that we just received in the cross multiplication method. You need to write this also while solving, and this, and later on this, or just from this line you can directly shift to this formula for x and y. Okay, and that would be okay using the cross multiplication method. You need to notice in the cross multiplication method that it is in the standard form, that is all the terms are on the left hand side, and on the right hand side you have only 0. But in the equations that we took, what was that? We had twice x minus 3y equal to 1. That was our first equation. Here one term is on the right, so you have to take it to the left hand side, and it will become twice x minus 3y minus 1 is equal to 0. So what is the value of a1? It is 2. What is the value of b1? It is minus 3. What is the value of c1? It is minus 1. And we shall use the cross multiplication method to solve this equation and the other one, which is 3x plus y equal to 7 by the cross multiplication method. We had this equation 2x minus 3y equal to 1 and 3x plus y equal to 7, and then we will bring all the terms on one side, and thus we shall have twice x minus 3y minus 1 equal to 0 and thrice x plus y minus 7 equal to 0. And from here we are going to write the coefficients of x and y and the constants also. And how do we write? We write the coefficients of x first or y first. So here the coefficient of y is minus 3, and then here the coefficient of y is 1. So we write it like this. Then we write the coefficient the constants, minus 1 here, and here we have minus 7, so minus 7. Then we write the coefficient of x, first equation 2. Don't mix up the coefficients, okay? If you are writing the coefficients of first equation on the numerator, you need to write it on the numerator only. And then what you have, 3, and then we need to repeat the coefficients of y and y on both the equations, right? And hence we have this result. So now we need to cross multiply them, and we need to write the value for x and y. So I am writing here, therefore x is equal to, we need to cross multiply 3 into minus 7, right? This is for x, this is for y, this is for 1 constant. It should be in the denominator, this part, right? So minus 3 into minus 7, 21. 1 into minus, then we need to subtract. 1 into minus 1 is minus 1, so we write it like this. Then we divide by the denominator, which is the constant part. So 2 into 1, ये तो हो गया 2 into 1, so this is 2. 3 into minus 3, so with the minus sign then we have to give 3 into minus 3, which is minus 9. So that is equal to 21 minus minus 1, that is equal to 21 plus 1. divided by 2 plus 9. So ultimately we have 22 by 11, which is equal to 2. Next we need to find for y. So for y, we know that which part we need to write? The middle one, minus 1 into 3, that is minus 3, then minus sign, and minus 7 into 2, which is minus 14. Then divided by the numerator, denominator is same as I told you, so just copying it. So minus 3 plus 14 divided by 11. So we have this minus 3 and 14 is 11 by 11, which is equal to 1. So our solution is x equal to 2 and y equal to 1. One note that you need to take care of is, if while solving you get a result where the x and y's get eliminated and in the substitution or elimination method, and while solving you get something like say 4 equal to 4 at the end, right? Instead of getting say x equal to something, right, you are getting a result of this kind, 4 equal to 4. That would mean that that pair of linear equations have infinitely many solutions. When the result is true for whatever value of x, this result is true, right, for whatever value of x, that would mean that the pair of linear equations has infinitely many solutions. Be careful with that, so don't get confused in that part. And if you are going to get a result, absurd result, something like that, 4 equal to 0, now this is always false, right? Or you can say this is a contradiction also, right? So whatever you say, always false or contradiction, if you get a contradictory result like this, then you can say that the pair of linear equations has no solution, that is they are parallel to each other. And in this case, when the result is always true for whatever the value of x and y are, then you can say that the pair of linear equations has infinitely many solutions. And all the other cases where you are going to get a value of x and you are going to get a value of y, a unique value, then definitely that's a unique solution, right? Otherwise you are going to get a result where it is always true or always false. So always true, infinitely many solutions. Always false, what solutions? No solution. So this is coinciding, right? And this should be parallel geometrically. Now we shall move on to equations which are reducible to linear form. Since we have already studied how to solve the linear equations, we are not going to solve the the equations which are reducible to linear equations except one, but we are going to form equations. And once we can form those equations, it is very easy to solve them using any of the technique that we have studied till now. So let us go for some questions where the equations given to us are reducible to linear equations. For example, these two equations where you can see it is not a polynomial of single variable that we can solve it. It is something different, but is it a linear equation? No, it is not a linear equation. But can we make it a linear equation? Yes, we can make it a linear equation, and for that you need to observe. So the first thing that you need to do is bring all of them on the same side and you see what happens here. An observation is a must here. So if you bring x on this side, it will become minus x, and minus x and minus 9x makes 10x, minus 10x, right? And we have minus 3y, and that would be equal to 0. And now if you take 2 common out of here, you will have x square minus 5x and minus 3y equal to 0, right? And in this part of the equation you can see x square minus 5x. Here also you can see x square minus 5x. So we are going to do a substitution where we are going to substitute x square minus 5x with a new variable called say u. Then we can write this first equation, and this equation as 1 can be written as, in place of x square minus 5x we are writing u. So u plus y is equal to 0, and from the second equation we can write that twice u minus 3y is equal to 0. Now this is the linear equation which is quite easy to solve, where the variables are u and y. So how do we solve this two? As you can see, if we just multiply the first equation here, these are implying, right? So if you multiply this equation, say let 3 and let this be 4. So if you multiply 3 with 2 and then subtract 4, then what will happen? So 2, not equation 2, so 2 into equation 3 minus equation 4. So what is our left hand side? It would be twice u plus twice y. This is the first part, right? After 2 is being multiplied to 3, this would become twice u twice y, then minus sign, then equation 4 we have, since minus sign, give the bracket always, we are not multiplying anything to equation 4, and that would be equal to 0, because on the right hand side also we need to multiply 2, but 2 into 0 is 0, and here you already have 0, so we get this result. And then you get that this, after removing the bracket, this 2y's 2u, as I'm saying, 2 u's get cancels, and you will have 2y minus, and this will be plus 3y equal to 0, and that would imply y is equal to 5y equal to 0, and that would give us therefore y is equal to 0. And similarly, if you put the value of y in any of the equation, say in equation 3, then what will 3 imply us? So 3 implies us that u plus y is equal to 0, right? So in place of y we write 0 is equal to 0, and hence we get u equal to 0. But what is u equal to? U is equal to x square minus 5x. That is what we substituted for u. So we can take x common, and we can have x minus 5 equal to 0, and hence we will have either of the result for x. X is equal to 0 or 5. So we will have two solutions here, because the y is same only, that is 0. So the required solution would be 0 comma 0 for x equal to 0, and this is y equal to 0, right? And we will have another solution where x is equal to 5 and y is equal to 0, right? So we had two solutions for these equations. What was our equation? Just look into that. We had x square minus 5x plus y, and twice x square minus 9x minus 3y equal to x. Now if I observe the equation, I would say that substitution was a better choice, because here I could have easily substituted u equal to minus y, and then in equation 2 I could get the result very easily. Let's move on to the next part. So this is your first question in exercise 3.6, where equations are to be reduced into linear form and then solve it. So if you observe here, you can see that the denominators have coefficients 2 and 3 on both, and hence we can multiply 6, and if you multiply 6, you will see that this 2 and this 3 will get removed, and on the numerator, instead of 1, we shall have, since it was 2 here, and it will be 3, and here it will be 2. Similarly here, if we multiply 6, then it will become 2, and this would become 3 on multiplying 6, right? And 6 have to be multiplied to the right hand side also, and hence it will become 12. And the last one, if we multiply 6 here, so this 6 and 6 get cancelled, and ultimately we will have 13. So on multiplying 6 to both the equations, you are having these new equations, right? And you can see that in both the equations you have 1 by x and 1 by y, 1 by x and 1 by y in the left hand side. So if you substitute 1 by x as u as 1 by x, and v as 1 by y, so the 1 by x here becomes u, and the 1 by y here becomes v, and you can see its equation as 3u plus 2v. Linear equations which is quite easy to solve, and here also it will be 2u and 3v. So we have a linear equations, right, and we can write it like this nicely. Let me remove this, and hence we have two linear equations, as this is a 12, this is 13, and when you solve these two linear equations by using any of the method, you are going to get the value of u and v. Whatever the value of u and v you are going to get, for this case you are going to get the value of u and v as it will be 39 minus 24 2v, so that would be 15 by 2. So substituting again 1 by y as 15 by 2, you are going to get y as 2 by 15, right? And hence you can substitute y also, and you can substitute v also to find the value of x. And if you substitute v, you are going to get the value of u, and then you can find the value of x. However, in the video for solving the exercises, we are going to do all these problems, hence no need to worry, but do try yourself. This is question number 3 of your exercise 3.6. What are you going to substitute for 4 by x and 3y? That y is already in the numerator, it doesn't have any power and everything, so we don't need to substitute for y. We can only substitute for 1 by x. For 1 by x we can write u, and hence it will become 4u plus 3y equal to 14, and 3u minus 4y equal to 23. Similarly, if you go for other equations, for this one, right, this is what number 5, 7x minus 2y by xy equal to 5, and 8x plus 7y by xy equal to 15. How would you solve it? So you just divide by xy, so it will become 7, x and x get cancelled by y, and then you will have 2 by y, and y get cancelled here, you will have x equal to 15, and then you can substitute 1 by y here and 1 by x here. So it will form an equation of this form, like 7u minus twice v equal to 15, and then this type of linear equation is very easy to solve, like using any of the previous method. Now this question number 17 of your exercise 3.6, what are you going to substitute here? You are going to substitute what? 1 by x plus y as u, and 1 by x minus y as v, and then the equation will be a linear equation in two variable, and you can solve it. The two variables will be u and v. You will get the value of u, you will get the value of v. But after you get the value of u and v, you have to, for example, you got the value of u to be 1 by 3. So what was u? U was 1 by x plus y, and that is equal to 1 by 3. So what will x plus y be equal to? That will be equal to 3. And now you will get a value for v also. For v also you are going to get similar kind of result, because v was taken to be 1 by x minus y. So you are going to get another result for x minus y equal to something. Say for example you got it to be 1 by 5. Okay, so here you will get x minus y as 5. Then you have to solve this equation and this equation. These two equations you have to solve again using the techniques of linear equation, but you have to do it 2 times, and in the exercise you are going to see it. Now you go to the next questions of your exercise 3.6, and you can see that you have word problems which have to be formulated first as an equation and then reduced to a linear equation. So going through them, understanding the language, knowing the definition is the primary thing to formulate it into the first equation. Once you can formulate it into the first equation, then by doing the substitutions that you have just seen, you can bring them into the form of a pair of linear equations. Now that would be simple, but formulating it into the first equation will require you an understanding of language. So understanding English language and understanding a few concepts related to the types of problem is very much necessary. Like this first problem that you can see is the downstream and upstream problem that is traveling on the river. Whenever you go downstream, that is, you are going along with the flow of the water, then your velocity and the velocity of water will get added together, because the velocity of water will give you a push so that you can move further. Hence, if we consider the velocity of your boat, for example, you are moving in a boat, or you might be swimming also, depends on the question. So if your velocity is taken to be x and the velocity of the stream is taken to be y, then when you are going downstream, the two velocities will get added. Obviously, you can understand why it will be added, because the water will be pushing you along its direction, right? But when you go upstream, that is, you are going against the force of water. So if this is your river, then this would be your downstream and this would be your upstream. Well, the river is not bent like this, it is not inclined, I'm just drawing it. So this is downstream and this is upstream, that is against the flow of water. The water is flowing on this direction, for example, and for upstream the water is going to resist you with the amount of velocity it has. Hence, your velocity and the velocity of water together combined, okay, when it is upstream or downstream, will be x plus y, and for upstream it will be x minus y. And using this concept and the concept of speed, distance, speed and distance formula, you know it, right? What was it? That was speed is equal to distance by time, right? So using that formula and this upstream and downstream concept, you are going to solve these equations and formulate it first, then bring it, substitute it into the linear equations, and then solve it, right? Next, you have the work and time problem. How many men and how many women are working? These type of problems came across while studying direct proportion and indirect proportion. If you remember that in direct proportion and in indirect proportion, the same kind of equations were formed, and in all those cases we always find the unit value and then we multiply the coefficients. We'll see how we do it. As you see in this problem, you have 2 women, 5 men can work together. So we need to take the unit value for 1 woman and 1 man. So let 1 woman be doing a work of 1 by x and 1 man be doing a work 1 by y. Now why 1 by x and 1 by y? Let it be that the entire work be represented by 1. We know that in fractions, how do we represent? The entire thing is, or the entire whole is being represented by the number 1. Or you can also say 100%. So how much of 100% is 1 person doing, right? So the amount of work 1 woman is doing or 1 man is doing, we take it to be x or y. So the part of work that woman or man will be doing will be 1 by x and 1 by y. So when we multiply it with the number of women, for example, how many women were there? We had 2 women and 5 men. So we can multiply it with 2, so it becomes 2 instead of 1, and it is 5, right? And together they are completing the work, right, in 4 days. So we need to write to be equal to 1 by 4, because 1 by 4 is the amount of work they will be doing in 1 day. In 4 days they are completing the entire work. So in 1 day they will be doing 1/4 of the work, hence this 1/4. And 1 by x is what? The amount of work 1 woman is doing in 1 day. So 2 women will be doing in 1 day will be 2 into 1 by x, which is ultimately 2 by x, right? And this is 5 by y. How do we get it? 1 man is completing the entire work in y days. Now you take the unitary method and then things might be more easier if you don't remember those things that are done earlier only. Okay, take it. So let us take this statement that 1 man completes the entire work, the whole work, that is the 100% of the work in y days. So if I take this y days and make it 1 day, then how much part of the work will it do? 1 by yth part of the work. And how many men are doing? 1 man complete 1 by yth part of the work in 1 day. And hence how much will 5 men do? 5 by yth part of the work, right, in 1 day. So that is what we are writing. This 5 by y comes here. That is 5 men is completing 5 by yth part of the work in 1 day. Now this concept totally lies whether your concept of fractions that was being taught to you in class 7 was clear or not. If not, then do inform me. And then all other problems related to this equations reducible to the form of linear equations can be discussed, but you should know the language, because you can't expect which questions are going to come in your exam. So converting the language into the form of equation is very, very important, and I'm repeating it. I am carrying it that I'm repeating the same thing, but converting the word problem into the equation is very, very, very important. For that you should understand the language and you should know the definitions. For example, if you have perimeter mentioned somewhere, you should understand what is the perimeter. If you have perimeter of a circle, then you should know that perimeter of circle is nothing but it is a circumference, and circumference is the formula 2 pi r, and all those things will help you in forming the equations. Therefore be careful in forming the equations. Once you can form the equations, then solving is very easy. Anyway, we have almost done all the theory part of this exercise, but the problems we are going to discuss while doing the exercise. Thank you. Chalo. Bye everyone.